Hi everyone, this is Dr. Nak. Today we're going to learn how to solve the systems of linear equations in 3 variables. We have learned how to solve systems of linear equations in 2 variables before. So it looks kind of like this, like maybe we can have 3x plus 5y equals to 10, and then maybe you had negative 2x, and then like maybe minus 5y equals to 2 or something like that. Now, they're linear equations because the exponent on both variables are 1. And furthermore, this is a linear equations in 2 variables because we have 2 variables, x and a y. Now, altogether, this is called the system of linear equations. Now, in this section, we're going to be given 3 equations and then 3 unknown variables, meaning we can have something like 3x plus 5y minus z equals to 10, and then you can have negative 3x minus y plus 2z equals to 1. I'm totally making something up right now. And then 2x plus y minus 3z equals to, I don't know, negative 3 or something like that. Now, all together, this forms the systems of linear equations in 3 variables. If you recall, solving systems of linear equations in 2 variables, we had 2 methods, right? Well, maybe 3. One is by graphing it out, and then second method is called the substitution method, and then another one is called the addition method. Now, we can use the same method to solve these systems of linear equations in 3 variables, but it gets a little bit hairy. So you're going to have to learn little tricks here and there, but we'll get there. Now, before we start doing some examples, let's go over the rules. Here are 3 rules for obtaining an equivalent system as the original system. So let's go with number 1. Interchange the order of any 2 equations. Number 2, multiply both sides of an equation by a non-zero constant. And number 3, add a non-zero multiple of one equation to another equation. Now, all those 3 properties are called the elementary row operations. It's basically telling you that you can do 1 and 2 and 3 to the original system, but your solution is going to be exactly the same as our original system. Now, for the 3 equations and 3 unknowns, your solution set is going to look something like this. Your solution set is going to be some value of x, some value of y, and then some value of z. Whereas if you're given the systems of linear equations in 2 variables, your solution set looks like solution set is whatever the x value is and whatever the y value is. With that said, let's take a look at an example. Example 1, determine whether the ordered triple 3, negative 3, negative 5 is the solution to the system 6x minus y plus 3z equals to 6, 3x plus 5y plus 2z equals to 0, and x plus y equals to 0. Now, if this ordered triple is a solution to the system, this solution must satisfy all 3 equations. So let's check. So let's go with the first equation. So let me just write 6 times 3, and then minus y is negative 3, minus 3, and then plus 3 times negative 5. So the question is that going to equal to 6? All right, so we got some little computation to do on the left-hand side, so let's do that. So here we're going to have 18 plus 3 and then minus 15, which is 21 and then minus 15. All right, that's going to equal to 6. Good. So our ordered triple satisfied the first equation. Now let's go with the second one. So the second equation, let's check, is 3 times 3 plus 5 times negative 3 plus 2 times negative 5. Now, I'm hoping, is that going to equal to 0 or not? I'm hoping it's going to be 0. But anyways, let's work on the left-hand side. So here we're going to have 9 minus 15 and then minus 10. So this becomes 19 minus 15 is minus 6, and then minus 10. Oh no, this is going to be negative 16, which does not equal to 0. So right there, we know that this ordered triple cannot be the solution to the system. Now, you know what? Just for heck of it, let's just check 3. Okay, so the 3 is x plus y. Is that going to equal to 0? So let me just go x is 3 plus y is negative 3. Now, is that going to give us a 0 back? Yes, it does. But since the ordered triple did not satisfy the second equation, our conclusion is that no, 3 comma negative 3 comma negative 5 is not the solution to the system. So let me just write that out somewhere. I'm running out of room. So therefore, no, 3 comma negative 3 comma negative 5 is not the solution. All right, so here's our answer. Okay, now let's go over some tricks to solve a systems in 3 equations and 3 unknowns. Now, if you're given 3 linear equations and 3 unknowns, we call that a 3 by 3 system. Now, let's take a look at this 3 by 3 system in this form. Now, this is 3 by 3. Now, x, y, and z are the variables, and then rest are all constants. Now, look at this. This is an upper triangular form, or sometimes we call it the stair-step pattern. Now, if we have it in this form, the system in this form, then do you see that I can easily solve for z? So from here, I can solve for z. Let me just go like this. So our z is just going to be k over h, whatever that number is. Now, next step, what we can do is this. Plug this z into the second equation, wherever you see your z, right? So if I do that, I know the expression is going to look pretty nasty, but just go with it. Then I can get e times y, and then plus f times z. So now this is some k over h. It's going to equal to g, right? So remember, y is the only variable, rest are all constant. And then from here, do you see that I can easily solve for y, right? I know it looks super nasty, but just bear with me here. So ey is going to equal to g minus f times k over h, whatever that number is. Now, if I divide it by e, then do you see that we can solve for y equals this nasty expression, right? So let me just, can I denote this by, what can I denote this by? Let's just call it m. So I'm calling this whole thing m. All right, now if I have y equals to m, I can back substitute this y into our first equation. Notice that we already know what the value of z is because we already got our z value here, right? So we already know what the value of y is and then what the value of z is. That means that, do you see that we can easily solve for x, right? So to solve a 3 by 3 system, if I were you, I will try to make this into a stair-step pattern, then back substitute to solve the system. And the process to make the system into a stair-step pattern or the upper triangular form is called the Gaussian elimination method. I think this is enough talking, so now let's take a look at some examples. Example 2, solve the system x minus 2y plus 3z equals to 9. Negative x plus 3y minus z equals to negative 6. And the third equation is 2x minus 5y plus 5z equals 17. And now I'm going to label our equation as 1, 2, and a 3. All right, so now let's try to make this into an upper triangular form, or you can say stair-step pattern. That means this. So this is the trick that I teach my linear algebra students. Now, you want to keep your x at the very top. That means that you want to get rid of these x's. Okay? Then after that, we'll deal with that after that. So let's first try to get rid of these x's by using the first equation. Okay, so notice that if I add 1 and 2, equation 1 and equation 2, do you see that I can get rid of this x, right? So that's exactly what I'm going to do to get rid of this x in equation 2. All right, so I'm going to write every step out. So as a side work, I am just going to go 1 plus 2. All right, so here what we're going to get is x minus 2y plus 3z equals to 9, and then negative x plus 3y minus z equals to negative 6. All right, so let's add them together. Now notice that this is going to cancel. That's exactly what we wanted. Now who's left over? We have negative 2y plus 3y, that's just y, and then plus 3z minus z is plus 2z, equals 9 minus 6, which is just 3. Next, I know it's a pain in the butt, but let me rewrite the new system. So what we just did as a side work, this now becomes x minus 2y plus 3z equals to 9. We didn't do anything to the first equation. I'm just going to leave it alone. Now that your second equation now becomes y plus 2z equals to 3. And equation 3, let's just leave it alone. We're going to have 2x minus 5y plus 5z equals to 17. All right. So again, now let me just call this first equation, second equation, and then third equation. Now, in order for us to make this into a stair-step pattern, I need to kill this one. I need to kill this 2x. So how can I kill this 2x? By using our first equation. You're right, multiply the first equation by negative 2. So if I multiply here by the negative 2, then I'm going to have a negative 2x, and then if I add 1 and 3 together, then I can kill this 2x. All right, so that's exactly what we're going to do. Now, just follow with me here. So first, what we're going to do next is negative 2 times the first equation, and then add that to the third equation. All right, and then write that result in where the third equation is at. Now, I should have done the same thing for our side work for the first one. So if I added equation 1 plus equation 2, what did I do? I put that result in where the equation 2 was. All right, so let's do this. So now let's go. Basically, what I'm going to do is I'm going to multiply by negative 2 to the whole entire first equation. All right, so then here what we're going to get is negative 2x, and then plus 4y minus 6z equals, don't forget to multiply by the negative 2 on the right hand side of the equation. So that's going to be negative 18. All right, so that was negative 2 times circle 1. Now I'm going to add that to equation 3. So equation 3, let me just copy and paste. You're going to have 2x minus 5y plus 5z equals to 17. All right, so now what I'm going to do is I'm going to add these two together. All right, so then I should have wrote that in black, just to keep the colors consistent. Sorry about that. Okay, so now let's kill that one. So then you're going to have 4y minus 5y. So you're just going to have negative y. And then negative 6z plus 5z. So you're going to have a negative z. That's going to equal to negative 18 plus 17 is just negative 1. So this expression here becomes your new third equation. Okay, so let me rewrite the whole system again. I know it's a pain in the butt. Okay, but let me just write it out. So now what do we got? We have x minus 2y plus 3z equals to 9, and then y plus 2z equals to 3. Now the third equation now becomes negative y minus z equals minus 1. So far so good. Okay, so our next step is this. If I'm going to make this into a stair-step pattern, do you see which one we need to get rid of next? You're right. This guy right here. You need to kill this one. So how can I kill this one? By using the first and second equation. Well, can I not kill this by adding the second equation to the third equation and then writing the result in the third equation? So let me just label this again. First equation, second equation, third equation. So what I'm going to do now is I'm going to add second equation plus the third equation and then write the result in where the third equation was. All right, so let's do it. So here you're going to have y plus 2z equals to 3, negative y minus z equals minus 1. All right, adding them together, I can kill the y's. Now here you're just going to have z equals to 2. Yay! So now that goes into the third equation was. All right, so let me rewrite. So then what do we got? We got x minus 2y plus 3z equals to 9, y plus 2z equals to 3, and then boom, we got z equals to 2. All right, so look at it. We already got the z value, so in order for us to get the y value, all you have to do is plug it in 2 in place of z into the second equation. All right, so let me just do that. So let's go with, okay, so that implies that we're gonna have y plus 2z, so 2 times 2 equals to 3. So that means that we're gonna have y plus 4 equals to 3. So our y is going to be negative 1. So actually, you know what? Let me box all of this. All right, so we got a z and a y. Now with that, we can solve for x. So I'm going to take the first equation here, and I'm going to write x minus 2 times y, which is negative 1, plus 3 times z, which is 2, equals to 9. So then here you're going to have x plus 2 plus 6 equals to 9, which is x plus 8 equals to 9. Subtracting by 8, we're going to have x equals to 1. Boom, done. I know it's a lot of writing the way we did it, but you don't have to write every step out, okay? But if I were you, I would. So that way you get more partial credit on your test, just in case you made a minor mistake somewhere. But anyways, we got ourselves a solution set. So therefore, the solution set is x is 1, y is negative 1, and then z is going to be 2. So here is our final answer. Now, if you don't want to write all these out, there is a little nicer way to do this. I don't know if you ever heard matrices before, but let me just show you how to solve the system by using a different notation, I should say. Let's take a look at example 3. So solve the system, but this is exactly the same system as in example 2. Okay, so I'm going to show you how to solve the system in a little bit of a cleaner way. All right, but anyways, I'm going to form a matrix out of this. Now, matrix is nothing but an array of numbers. All right, but what I'm going to do is I'm going to take the coefficient on x, coefficient on y, coefficient on z, and then tag along with the 9. Okay, so the coefficient on the x is 1. So here I'm going to write it as 1. Now the coefficient on y is minus 2. So I'm going to write it as negative 2. And then coefficient on z is positive 3, right? So I'm just going to write it as 3. And then let me just make a slash right here. And then on the right hand side, I'm just going to write down the constant value. All right, and then we're going to do the same thing for the second equation and then the third equation. So for the second equation, we're going to have negative 1, 3, negative 1, and negative 6, and then 2, negative 5, and a 5, and a 17. Now, this whole thing together is called the augmented matrix. And we call this is a first row, and then this is our second row, and then this is our third row. All right, so this is just a cleaner way to do it. You don't have to write so much. So let's try to make this in the stair-step pattern, which means that I need to get rid of this, and then I need to get rid of this. All right, so let me just write this as, you know what, let me just write it as row 1, and then this is row 2, and then this is row 3. Okay, so first what I'm going to do is this. I'm going to add row 1 plus the row 2, and I'm going to write the result in row 2. Okay, so if I do that, let me just take it as a side work. You're going to be adding 1, negative 2, 3, 9. So that's our row 1. And I'm just going to write down our row 2, which is negative 1, 3, negative 1, and negative 6. And I'm going to add them together. So then do you see that this is going to cancel out? That's exactly what we wanted. Now add vertically. Then you're going to have 1, 2, and a 3. So that's nothing but the coefficient on your y, z, and then the 3 becomes the new constant. Okay, so this becomes your new row 2. So I'm going to rewrite that matrix now. So I didn't touch anything on the first one, nor the third one. So I'm going to write 1, negative 2, 3, and a 9. Now, the bottom one now becomes 0, 1, and a 2, and a 3. All right, and then the bottom one, just leave it alone because I haven't touched that one yet. So far, so good? Okay, so now our next step is this. Again, we're trying to make this in the upper triangular form or the stair-step pattern. So that means that I need to keep this one here, but I need to get rid of that. I need to make that into a 0. So what do I need to do? I need to multiply by negative 2 to row 1, add that to row 3, and write the result in row 3. Does that make sense? So let me just write this as row 1, row 2, and then row 3. So now what I'm going to do is this. On the next step, what I'm going to write is negative 2 row 1 plus row 3, and then write the result in row 3. All right, so let's do that. Now if I bring that as a side work, negative 2 row 1, I'm going to have negative 2. So do you see what I'm doing? I'm multiplying this whole first row by negative 2. That's what I'm doing here. Can you see that? Sorry, this is a negative 2. So you're going to have a negative 2, 4, negative 6, and then negative 18. And row 3 is just 2, negative 5, 5, and a 17. Now we're going to add them together, and then this is going to cancel out, which is good. Now add vertically, you're going to have a negative 1, and then another negative 1. So that's nothing but a coefficient on your y, z, and then last negative 1 is the constant term. All right, so that becomes your new row 3. Okay, so I'm going to rewrite our matrix now. All right, so we're going to have 1, negative 2, 3, 9, and then 0, 1, 2, 3. Now this becomes 0, negative 1, and another negative 1. Okay, so now next step is this. In order for us to make this into an upper triangular form, I need to kill this negative 1 here. So how do I kill it? Well, why don't we use the second equation, add that to the third, and then write the result in the third row. Right? That's exactly what I'm going to do. Okay, so let me just write my operation. So what I'm going to do is just, let me just call row 1, row 2, row 3. So I'm just going to add row 2 plus the row 3 and then write the result in row 3. So as a side work, let me just copy down our row 2, which is 0, 1, 2, 3. And then row 3 is 0, negative 1, negative 1, negative 1. So I'm going to add them together. So you're going to have a 0, 0, and then 1 and a 1. Oh, just kidding. The last one should be 2. Sorry about that. 3 minus 1 is 2. Okay, so now we're going to write that result in the third row. So now that becomes, so this becomes the coefficient on x, coefficient on y, coefficient on z, so this becomes the constant. So here, we already got the z value now. So if I rewrite that matrix, we're going to have 1, negative 2, 3, and a 9. 0, 1, 2, 3, and then you're going to have 0, 0, 1, and 2. All right, so that the third row tells us that this guy right here, this tells us that z is going to be 2. All right, and then what do we have on the second line is this. Our second line translates as 1y plus 2z equals to 3. And the first row is translated as 1x minus 2y plus 3 equals to 9. Isn't that exactly what we had in example 2? Right? So this is just a cleaner way to do it. You don't have to write all the systems, over and over and over. But from here, we should get to the same answer, because if I plugged it in z equals to 2 in place of z for the second equation, then what we're going to get is y plus 2 times 2 equals to 3. So y is going to be negative 1. Let me just box our z equals to 2. Now plug that y and a z value into the first equation to solve for x. So from here, I'm like all over the place right now. So from here, I'm just going to write it as x minus 2 times y, which is negative 1, and then plus let's do this example. Example 4, solve 3x minus 1/2 y minus z equals to negative 1/2, 4x plus z equals to 3, and then negative x plus 3 over 2y equals 5 over 2. Yikes, I know. You see fractions and you just want to run away, but don't. There is an easier way to do this. So step number 1, let's try to get rid of those fractions, right? So it might look a little bit more friendly looking. So all you have to do is this: multiply each equation by the least common denominator. So let's take a look at the first equation, right? So the first equation, the common denominator, least common denominator is going to be 2. So multiply the first equation by 2. All right, so then here, just gonna write it on here if that's okay with you. Multiply everything by 2. And then second equation, there's no fractions, that's good to go. Now let's look at the third equation, right? So third equation, what's the least LCD? 2. So I'm also gonna multiply the third equation by 2. Okay, so let me just rewrite the system. So if I multiply by 2, then you're gonna, please distribute this 2 in. All right, that's exactly what we're going to do next. And don't forget to distribute on the right hand side as well. Okay, so then the new system is going to be 6x and then minus y minus 2z equals to negative 1. And then let me line up all the x's and all the y's and z's. Okay, so then next equation, I'm going to write it as 4x plus z equals to 3. Now the third equation becomes negative 2x and then plus 3y equals to 5. See? Much nicer, right? Okay, so from here, feel free to use the matrix method if you like. But first, let me swap the ordering of these equations. So what I want to do is this. I want this negative 2x plus 3y equals to 5 to appear at the very beginning. So that way, I can keep the first equation, right? And then if I multiply by 3 to that, I can kill the 6. Multiply by 2 to that, I can kill that 4. So let me just rewrite the system like this. Negative 2x plus 3y equals to 5. And then from there, I don't care which one you put first, 6x, the first equation or the second equation. It doesn't really matter, but let me just keep it as 6x minus y minus 2z equals to negative 1. And then we have 4x plus z equals to 3. So all I did was I just rearranged the equations, that's all. All right, so let me just call this, instead of circle 1, circle 2, circle 3, let me just call this row 1, and then row 2, and then row 3. Okay, so first what we're going to do is this. Oh, man, I so want to use the matrix method. It's so much cleaner, but all right, so let's just, I'm going to suck it up and do this. All right, so ready? So first what I'm going to do is this. in order for us to make this into a stair-step pattern, I need to kill this 6x, I need to kill that 4x. So I can use the first row and then kill the 6x and then 4x. So first, let's kill the 6x. So that means what? I need to multiply the first equation, row 1, by 3, right? So then let me just write that out. So this is all going to be my side work on the right-hand side of it. So what I'm going to do is 3 row 1, and then plus row 2, and then we're going to write that new result in row 2. All right, so if I do that, then let me see. You're gonna have, let me multiply by 3 to row 1. So I'm gonna multiply this by all 3. So what do we get? Negative 6x plus 9y equals, don't forget to multiply by the 3 on the right hand side. So you're gonna have 15. And then row 2 is just 6x and then minus y minus 2z equals the negative 1. All right, I'm going to add them together. So this is going to cancel out. That's exactly what we wanted. Now you're going to have 8y minus 2z equals 14. Now, if you want to make this a little bit simpler, you can divide this whole equation by 2 if you like. All right, but anyways, let me just keep it that way. So this becomes your new row 2, this guy right here. All right, so let me rewrite. So we got negative 2x plus 3y equals to 5. Now new row 2 becomes 8y minus 2z equals to 14. And then third equation, 4x plus z equals to 3. All right, we got this. So now let me label row 1, row 2, and then row 3 again. Okay, so our next mission is kill the 4x, make that into a 0, right? So what do I need to do? Multiply the first row by 2, add that to row 3, and then write the result in row 3. So that's exactly what we're going to do. So what the heck did I just say? Multiply the row 1 by 2. Okay, so ready? So I'm going to get, oh, let me just write down the operation. You're going to go 2 times row 1, add that to row 3, and then write the result in row 3. Okay, so then what do we get? You're going to have a negative 4x and then 6y equals 10. And then you're going to have 4x plus z equals to 3. Add them together, then this is going to cancel out. So we have 6y plus z equals to 13. So that becomes your new row 3. Okay, rewrite. So you're going to have negative 2x plus 3y equals to 5. 8y minus 2z equals to 14. And then we're going to have 6y plus z equals 13. Now notice that the second equation, right? If I multiply by 1/2, or same thing as dividing by 2, do you see that I can simplify this equation a little bit? So let me do that. Okay, so let me just call this one, changing the color, row 1, row 2, and then row 3. I'm going to write every step out. So what I'm going to do is I'm going to multiply row 2 by 1/2. Okay, so you see what's going to happen in a minute. So the next step, I'm going to go 1/2 row 2 and then write the result in row 2. Then if I do that, then just same thing as dividing by 2. Okay, so then if I do that, then you're going to have 4y minus z equals 7. Little bit nicer, right? So let me rewrite. Oh no, I'm going to run out of room, but let me just rewrite it here. And so you got negative 2x plus 3y equals to 5. And now we have 4y minus z equals to 7. And then you're going to have 6y plus z equals 13. All right, so let me try to copy and paste to the next page. All right, so I just copy and pasted the system, the new system that we just got. Now here, right, I mean, you don't necessarily have to make it into a stair-step pattern or upper triangular form to solve the system. All right, but in this case, right, do you see that if I just add the second equation and third equation, and then I can get rid of that z, so that way I can solve for y. Okay, although this is not going to be a stair-step pattern, but that is okay. All right, so let me just denote this by row 1, row 2, and then row 3. Okay, so the next step, what I'm going to do is I'm just going to add row 2 plus the row 3, and then let's just write the result in row 3. Okay, so then if I do that, then I'm going to have a 4y minus z equals to 7, 6y plus z equals to 13, add, then you're going to have a 10y, and then this is going to cancel out, and this is going to become 20. So look at it. We have y equals to 2. Now you don't necessarily need to rewrite the system again, but just to, keep it the same way as I did in example 2, let me just rewrite it as negative 2x plus 3y equals to 5. And then you're going to have 4y minus z equals to 7. And now you're going to have 10y equals to 20. And from here, we know that y is 2. Now, let's plug that y equals to 2 into the second equation to solve for z. So now I'm going to take this guy here. I'm going to go 4 times 2 minus z equals to 7. So here you're going to have 8 minus z equals to 7. So our z is going to be 1. Let me box that. Now we can find our x. Okay, so then lastly, let me just take our first equation and then plug the y for 2 and then 1 for z. 2 for y, 1 for z. Sorry, I'm tired. Okay, then you're going to have negative 2x plus 3 times 2. So this is going to equal to 5. Oh, I guess I didn't need to plug it in z, huh? All right, so then here you're going to have negative 2x plus 6 equals to 5. So you're going to have negative 2x equals to negative 1. So our x looks like it's going to be 1/2. So let me box that. Let's write down our final answer. So therefore the solution set is 1/2, y is 2, and then z is 1. And we're done. Let's take a look at example 5. Solve the system. First equation is 4 over 5x minus 7 over 8y plus 1/2 z equals to 1. Second equation is negative 4/5 x minus 3/4 y plus 1/3 z equals negative 8. And the third equation is negative 2 over 5x minus 7 over 8y plus 1/2 z equals negative 5. Now from here, you can do whatever you like, but I think I might want to get rid of the fractions first, if that's okay with you all. Or feel free to add the fractions together and then eliminate the x and so forth. But let me just try to get rid of those fractions. All right, so I'm going to apply that same trick. I'm going to multiply the first equation by the LCD, which is 40. And the second one, what's the LCD? 60. And the last equation, 5, 8, and a 2, that's another 40. Okay, so let me rewrite the system by distributing the 40 to each term, and then 60 to each term, and then you know what to do. All right, so let's do it. So first, if I distribute that, what the heck do I get? 32x minus 35y plus 20z equals to 40. And then the next one, 60, and then multiply that by negative 4/5, negative 48x minus 45y plus 20z equals negative 480. And then negative 16x minus 35y and then plus 20z equals negative 200. I hope I didn't make any mistakes at the first step. All right, so now let's take a look at this. Okay, so first let me do this. Let me swap row 1 and row 3. So let me call this one row 1, row 2, row 3. Let me swap row 1 and then row 3. You'll see why in a minute. Okay, so if I do that, then I'm going to rewrite this as negative 16x minus 35y plus 20z equals to negative 200. And then negative 48x minus 45y plus 20z equals negative 480. And then 32x minus 35y plus 20z equals 240. All right, so now let me use negative 16 to get rid of negative 48 and then 32, right? Coefficient on x. So here, if I multiply the first row by negative 3, so negative 3 row 1 plus the row 2, write the result in row 2, then do you see that I can get rid of that negative 48x? So let me just do that. So I'm going to multiply this whole thing by negative 3. Okay, so let me distribute that and then let's rewrite. So if I rewrite that, then what are we going to get here? Okay, we're going to get 48x. Let me just go over here. 48x and then plus negative 3 times negative 35, that's 105. Y and then minus 60z equals 600. Oh man. Okay, and then negative 48x and then minus 45y plus the 20z equals the negative 480. And we're going to add that together. Oh, goodness gracious, this is going to cancel out. And then we're still going to have 60y minus 40z equals 120. So that's going to become our new row 2. So let me rewrite. Negative 16x minus 35y plus 20z equals negative 200. The new row 2 becomes 60y and then minus 40z, and that's going to equal to 120. And then third row, we got 32x minus 35y plus 20z equals to 40. All right, we got this. We're not going to give up. Okay, so here let's call this one row 1, row 2, and then row 3. So now what I'm going to do is multiply the row 1 by 2, add that to row 3, and then write the result in row 3. So that way I can get rid of that 32x. All right, so then if I do that, what are we going to get? So here you're going to have 2 times row 1. So I'm going to multiply this by 2. So then what we're going to get is negative 32x and then minus 70y and then plus 40z equals negative 400. Row 3 is 32x, that's at 32, sorry, and then minus 35y plus the 20z equals to 40. All right, let's add them together. So this is going to cancel out. Now, what do we get? Negative 105y and then plus 60z equals to negative 360. All right, that's going to become our new row 3. So let me rewrite. Oh, goodness. Negative 16x minus 35y plus 20z equals negative 200. And then we have 60y minus 40z equals 120. And then we're going to have negative 105y plus 60z equals negative 360. Okay, so let me copy and paste this new system onto the next page. All right, so here's the system that we just got. I just copy and pasted it. Okay, so now let's look at equation 2, right? The second row. Can I not divide everything by 20 to simplify it a little bit? So that's the same thing as multiplying the row 2 by 1 over 20. So that's what we're going to do. Okay, so let me call this one row 1, row 2, and then row 3 again. Now the next operation is going to be 1 over 20 times row 2, and then rewrite that in row 2. Right, so then if I divide by that 20, then our new row 2 is going to become, what is that? 60y minus 40z equals to 120. So basically we're dividing everything by 20. So then you're gonna have 3y and then minus 2z equals to 6. All right, so that's gonna be our new row 2. So let's rewrite. So then you're gonna have negative 16x minus 35y plus 20 equals to negative 200, and then 3y minus 20z here equals to, goodness, let me just erase that, equals to negative 200, and then 3y minus 2z equals to 6. And then can I not simplify the row 3 as well? I think we can. So 15 should go into 105, 60, and 360, right? So what I'm going to do is this. Let's just do 2 operations at once. So here I'm going to write it as 1 over 15 times row 3. Write the result in row 3. That's the same thing as divide each term by 15. So if I do that, then let's see, let me just write down row 3. So we got negative 105y plus the 60z equals to negative 360. So basically I'm going to divide each term by 15. Okay, so then what are we going to get? Negative 7y, and then plus, what is that, 4? Yeah, 4z equals negative 24. All right, so let me rewrite the third row as negative 7y plus 4z equals negative 24, and I want to cry. All right, no, we do not give up. We got this. Okay, so, oh, look, can I not kill that z? Like if I multiply the second row by 2, right, then this becomes 4z, and then I can kill that one. Let's do that. Oh, suddenly I'm so excited. Okay, so let me just call this one, let's call it row 1, row 2, and then row 3. Okay, next what I'm going to do is multiply 2 to row 2, add that to row 3, and then write the result in row 3. Okay, so let's do it. So first I need to multiply this guy by 2, right? So then what are we gonna get? 6y minus 4z equals 12. And the third row is negative 7y plus 4z equals negative 24. All right, now if I add this, this is gonna cancel out, and then you're gonna have negative y equals to negative 12. Oh, look at that, yay! And dividing up by negative, so that implies that y equals to 12. Yes, so once we got the y equals to 12, then I can solve for z, and then I can solve for x. Yes. Okay, so let's do this. So now I'm going to plug y equals to 12 into the second equation. Okay, so then you're gonna have 3 times y. So let me plug this into row 2. Okay, so then that's my next step. So here what we're gonna get is 3 times what is that, 12 minus 2z equals to 6. So 36 minus 2z equals to 6. So then 2z equals to 30. So z is going to be 15. All right, we're home safe. Okay, now let's get our x by plugging these values into the first equation, which is row 1. So now we're going to get negative 16x minus 35 times y, which is 12, and then plus 20 times z, which is 15, equals negative 200. So that's negative 16x, and then minus, what is that, 35 times 12 is 420, and then plus 20 times 15, oh, my brain's dead right now, 300, equals to negative 200, which is negative 16x, and then combine that, negative 120 equals to negative 200. Now add 120 to both sides, then you're gonna get negative 16x equals to, add 120, so that's negative 80. Now dividing by negative 16, and x is going to be positive 5. Yay! See? We didn't give up, and we got ourselves a solution set. Okay, all that work. All right, so therefore, the solution set is x is 5, y is 12, and then z is 15. I told you we got this. All right, so this is going to be our final answer. All right, now let's take a look at this word problem. So let's call this one example 6. It says 3 even numbers sum up to 108. The smaller is half the larger, and the middle number is 3/4 the larger. What are the 3 numbers? So here we got 3 things going on. So we got 3 even numbers. We have a small, medium, and large, right? So let me just let S be the smallest number, and then let M be the middle number, and then L be the large number. Okay, so we know that all 3 numbers, if I add them up, it's going to add up to 108. So let's translate that in math notation. So that's S plus M plus L. That's all going to add up to 108. Now let's read the next sentence. The smaller is half the larger. Okay, so that means that we know that the smaller is half of the larger. And then the middle number is 3/4 the larger. So middle number is 3/4 of larger. Okay, so now I think we can solve for L from here by plugging those S and M into the equation. So I'm going to take this equation and then replace S with 1/2 L, and then M with 3/4 L, and then we're gonna have another 1 L equals to 108, right? So now I need to get common denominator, so that will be LCD of 4. So that means I'm gonna multiply this guy by 2/2, and then this guy by 4/4. Okay, so then if I do that, then you're gonna have 2/4L plus 3/4L, and then plus 4/4L equals 108. Now, since we got the common denominator, I can add the numerators together. So you're going to have 9/4L equals 108. Okay, now solving for L, what do we do? Just multiply it by the reciprocal of 9/4, which is 4/9, to both sides. So then here we're going to have L equals, what is that, 80? All right, so we got our largest number. Now using that, I should be able to plug that into our equation for S and then M. So this implies that our S is 1/2 times L, so it's going to be 1/2 times 80, which is going to be 40. And then the middle number is 3/4 of the largest, which is 80. So this is going to be 60. Yay, so this wasn't that bad compared to last example. All right, so now let's word this out. So the smallest number is 40. The middle number is 60. And the largest number is 80. And we're done. Not too bad, right? So how you all feeling? Are you kind of like brain dead like I am now by doing the example 5, I think? But anyways, look at it. We didn't give up and we're able to solve it. So lesson learned. Just because that expression looks nasty, that does not mean that you should skip it, because we can do it. But anyways, I'm going to stop here. So if you have any questions at all, please let me know. And good job, everyone. Now go get some rest.